Daniel T, could you read exercise 7, number 3, please?
So in parallelogram ABCD, AB equals x plus 8, BC equals 3x, and CD equals 4x minus 4. ABCD must be a...
Okay, thank you. So since the geometry step number 1, this exercise 7, number 3, make a picture. They said parallelogram. Make this parallelogram. In parallelogram, opposite sides are parallel. And they give you A, B, C, D. And they said AB x plus, what is it, x plus 8. BC, where is BC? 3x's. CD for x minus 4. And they ask you what kind of quadrilateral is it? Because parallelogram, remember, is a relationship I explained you from object-oriented programming last time, right? And look at this property of parallelogram. Opposite sides are parallel, and opposite sides are congruent, the same. So if this 3x, and this equals to each other, from this simple equation, x plus 8 equals 4x minus 4, you can easily find x. How? Minus x and minus x, plus 4 and plus 4. Cancel out. 12 equals to 3x. If you divide both part by 3, you easily get what? X equals to 4. So it means this side 3x equals to 12. This side, if you plug in here 4 plus 8, this is 12. Without even checking, this also 12 because the opposite sides of parallelogram are congruent. 12. And this is 12. So parallelogram, all sides are the same, congruent. How we name it, Daniel? Rhombus. Okay. Any question about this? You have to start the definition in the beginning. This is exercise number 7. It was number 3. Okay. Exercise 9. Very fast. Exercise 9. Let me find this exercise. I go through most request question first. Number 5, Alexander, please. Exercise, let me check if you're unmuted. Yes, you're unmuted. Okay.
The base of a rectangle tank is 6 feet by 5 feet, and its height is 16 inches. Find the number of cubic feet of water in the tank when it is 5 or 8 full.
Thank you. So this is exercise 9, number 5. Geometry, step number 1, picture always, right? Make it solid. They have this like rectangular tank, rectangle. So let me make this tank. And now they said 10 inches, what is it? 6 feet by, they said by 5 feet. And height is 16 inches. 16 inches. This is length, this is width, and this is height is 16 inches. Rule of thumb, if you have to find volume, everything must be in the same unit of measurement. You know 1 foot is 12 inches, right? Convert everything to feet. It would be 16 over 12, or after simplification by 4, it would be 4 over 3 feet. Beautiful. Everything in the same unit of measurement. Like we did in 4th grade, volume equals length times width times height. 6 times 5 times 4 over 3. 3 goes into 6 2 times. 10 times 4 is 40. 40 cubic feet. What is it? This is volume of 10. But they said they put some water over this. How much? Find the number of cubic feet if it's 5 over 8 full. If 5 over 8 full, I put some water here. Okay. To find this. Made in China. The same result. Pretend this is water. And this is 5 over 8 of this. Of this tank. Of this volume. And the question is, how much water is here? Easy. The volume of water. It's not inches, it's 5 over 8 of this amount. All means multiplication. Take this 40, multiply by 5 over 8. 8 goes into 45 times. And I have 25 cubic feet of water. This is water, 25. So far, so good, students. Any questions? Actually, what grade is this question behind this scene? Volume of prism you study in 4th grade. This is 4th grade Common Core curriculum. And you know in math, of means multiplication. Just multiply by this fraction. Who understand up to this point everything? Raise your hand, students. Everybody. Okay, hands down. If you have any question, ask me. So again, I go first of all through mostly class questions. Okay. Now test 26. Test 26. Where is this test? Let me find it now. Again, I show a few of these, few examples, mostly class questions. And the rest of them based on the same idea. For instance, many students ask me number 2. Number 2, I believe everybody unmuted. Arthur, would you like to read number 2 out loud? Let me check if I unmute. Yes.
How many sides does a polygon have if the sum of its interior angle is 1,440?
Thank you. So it's interrelated, this exercise interrelated with your exercises 7 and 9, what you did at home. And you remember, we started with your formula. This is number 2. 26, 2. What they said, sum of interior angle, sum on the interior, the sum of interior angle equals to what? 1440. How to find total of interior angle? We study formula. Total of interior angles of any polygon, and you have it, I want to show that it's interrelated. It's chapter 13. Open this handout and put, since many students ask, I give you this page. I will give you this page with formulas. This is a page number, just a second. Okay, you can find this. It's supposed to be 180 times n minus 2. I don't remember what page is it, but anyway. Okay, so total equals to 180 degrees times n minus 2. What is it? Is total of inner angle of any polygon, where n is number of sides. N is number of sides. And you know this equal 1440. There are two ways. Either divide, this is equation. Either divide both part by 180 or use distributive and solve equation. It would be, let's say, distributive 180n minus 360 equals 1440 plus 360 and plus 360. Bring down 180n, cross it out, equals 1800. Divide by 180 both parts. Equals to 10. Who can find where is this formula? I want to just show. I believe you didn't study your homework. Who remember what page is it with formula? We did with you, remember? Remember this one. Anyway, put in a frame, and you're supposed to know this. I believe we covered it one day with you. 180 times n minus 2. I just remind, pretend we have a polygon, any polygon. Let's say we have pentagon. And let's say we have regular pentagon. In regular polygon, all sides and all angles are the same. Okay, regular. If you need to find total inner angles of any polygon, in this case pentagon, use this formula and plug in instead of n5. If they ask you to find any angle, inner, interior angle, any angles, all of them the same, what are you supposed to do? General formula, 180 times n minus 2, and divide by number of sides of number of angles. Okay? So far, so good? Let's say if you find 540 total, and one angle, how to find one angle? Divide by 5. That's about it. All examples from this exercise just develop your skill. Let me solve another problem with you. Most request questions, what you ask. This is chapter. Understand up to this point what you're doing. Okay, good. Hands down. Let me go through another question. Another question. For instance, one more. Where you have most students. Number 4. Who would like Daniel O, please? Number 4. 26, 4. Check.
I don't have the copy.
Not good. You have to have digital format. You got email this. Okay. Eric, 26, 4, please.
Number 4.
Yes.
Each of the interior angles of a regular polygon is 160 degrees. How many sides does the polygon have?
Okay. Thank you. So how to find each angle? You have to find total. This is total. 180 times n minus 2. Where n is number of sides or number of angles. How to find one angle? One angle. If polygon is regular, you have to divide by n everything, right? Let's say, I give example. Simplest example ever. Triangle, 180 degrees. Equilateral, 3 sides. How to find one angle? 180 divided by 3, 60 degrees. Same idea. And this equals to, what they said? It's equals to 160. Why? Because this is one angle. One angle is 160. Well, you can think 160 is the same 160 over 1. Okay. And make cross multiplication. 180 times n minus 2 equals to 160n. Distributive. 180n minus 360 equals to 160n. Okay. So minus 180n and minus 180n. Cancel out. Negative 360 equals to negative 20n. How to find n? Divide both part by negative 20. So all exercises from this and out based on this, and this formulas. Okay, and you simplify, this would be 18. N equals to 18. Okay. Practically all question, if you understand these two problems, you understand everything from this package. Do you have any questions about these, students?
Dr. Farber, can I go to the bathroom, please?
Sure. So let me put this way, everybody can go to the bathroom. We already work exactly 1 hour. You come back and raise your hand and we continue. Everybody. Okay. Come back and hand. Yes.
Can you please go over 6?
Sure, I will, but go to bathroom, come back. You need to be concentrated on this, right?
Dr. Farber. Where did it go? Dr. Farber.
Yes, question.
I have the copy.
You have to be prepared, Daniel. You have to, before class, prepare everything, because if you don't read the question every time, you're losing 50% of information. Make sense? Every class, you know, you have to have handout in front of you. You found this, right?
Yes.
Good. So before class, my suggestion are create a folder if you don't print it out by dates. Every time everything is stored in your folder because it helps you to review for preparation for final. When you have a few months left, you go over through these copies. Organize in your hard drive. You know how to use Windows Explorer, I believe, right? How to create folder, how to store everything by dates. Okay, soon. If you come back, raise hand. Waiting for you. Only 2 students came back. Okay, let me make a picture. Somebody asked me number 6, and when you come back, I start explanation. (22) 6. And picture like this. You also make picture practice. And I put some E, D, and B and C. This is 110. This is 114. This is 16. This is X. This is 20. Okay. Who asked me this question? Raise your hand. Who asked me these questions? Okay. If you have this question, can you tell me what shape we have here? How do you name this shape? Anybody? Yeah, just tell. Use microphone, tell, name it.
A pentagon.
Pentagon, 5 sides. Only compared to this pentagon, where all sides are the same. And we name it regular. This irregular, but this still same pentagon. Like we did in previous problem, in order to find x, step number 1, you can easily find total of inner angles of any polygon. Since this is pentagon, we have 5. You have 180 times 5 minus 2, which is 3. 3 times 180 is 540. What is 540? This is the sum of interior angles. Step number 1. I take different color. Let's say green one. And ask you how you name this green angle. And this point. Who knows how you name this green angle? Yes, sorry?
Reflex.
Reflex angle. Yes, reflex. And you know what is reflex, right? if I show you angles, for instance, look at this. This is acute. This is right. This is obtuse, more than 180. And this, if it goes like this way, is reflex. Reflex is greater than 180 and less than 360. So you can easily find this angle E, I will name it reflex. This step number 1. Step number 2. Angle E, I will name it reflex. Equals 360 minus x. And what the difference? This angle is inner angle. And you can easily write total of inner angles of this pentagon. If I start from here, 110 plus 60 plus this E, 360 minus x plus 20 plus 114. And this already used. It's supposed to equal 540. Why? Because it's total interior angles of any polygon. So far so good. So combine like terms and find x. We need help with this, how to solve this simple equation. Let me move forward, right? The idea is the same. So not necessarily we have two different kind of shape, convex and concave. This goes inside like this, but it's still pentagon. If it's pentagon and this is polygon, this formula applicable for any, doesn't matter what kind of shape you have. I have a question for you. Can I find one angle dividing this total by n by 5? No. Why? Because all angles not the same. It's not regular pentagon. Who understand this problem 100%? 100. Good. Let me move forward because I need time for new topic as well, right? Don't forget. We can afford not to do new topics. So this you redo, just develop your skill. Practice is do it faster. It's not complicated problem. Next, package 32. 32. Also go through a few questions. For instance, Daniel O, read please number 1, 32-1. Проверь, пожалуйста, чтобы все были unmuted. Can you read this? You asked me this question. Daniel O. No? Okay, yes, go ahead.
What question? What number?
Package 32, number 1.
What is the surface area of the right prism?
Thank you. First of all, make this prism and connect these vertices. Okay. And they give dimension. Well, this is length. This is width is 7. And height is 8. For my programmer student, I show in Java how to, using two-dimensional methods, how to create this three-dimensional. You have in Java method, draw rectangles. So I build one rectangle. After that, provide coordinates, build another rectangle. After that, we have a method, draw lines. And program drew these lines. And I have a rectangle. Now, Don't memorize any formulas, just common sense. Look at this, how to find area total. You have to find front and back area are the same, left and right the same, top and bottom. So far, so good. Area front and back equals 12, and this is 8. 12 times 8 for day. And you have to multiply by 2. Why? Because we have this one, and we have this one back. So far, so good. Questions? Do the same procedure from area left and right. This is 7 by 8. And multiply by 2 because we have left and right. They are identical, congruent. Eventually, area top and bottom. This is top, this is bottom. They have dimension 12 by 7. And multiply by 2. How to find total? Surface area. Area surface. Add them up. If you multiply them up, you get total area. So, question for you, student. Who understands this 100%? Minimum memorization, just imagination and formulas. That's it. Eric, you understand? Hands up. Eric. What do you think? Question for you, student. What do you think? Can you get this question on your SHSAT test? Yes or no? Who think you can get this on SHSAT test? This kind of question. Who think we cannot get this kind of questions? We cannot get this too, because it's too easy, student. This is fourth grade curriculum. We did the same in fourth grade. Why? Because in fourth grade, you know how to study area. You study how to find area of rectangle, length times width. Just add them up. That's it. But if you don't understand this question, you will not solve a real question from real test. In real test, we have a lot of practicing after this during summer. What they do in this case, for instance, look at this. I give a real test question. They make holes here. Okay. For instance, 2 holes. And in these holes, they specify, for instance, this is, let's say, 1 by 1, these 2 holes. But this is not just hole here, they go through entire prism. And this goes through entire prism. On the test, you have to find this surface area. And this is absolutely different animal. Use the same idea, but not everybody solve it without mistake, this one. You will see during summer. Real question for me, real test. So this is steps which help you to win. Okay, understand difference? You will see we have a lot of tests written in my corporations based on previous years. We will see this kind of question. Or they can give another one. Let's say you have this one, this prism, right? And they have cylindrical hole. What about this one? They provide the diameter of this, and you have to find surface area. This is different question. Well, let me go through another one. So practical, all of them so easy. All this question easy. You're not supposed to memorize anything. Okay, let me do any of this where you have more questions. For instance, 15 many students ask. 15, 32, 15. And who would like, Nicholas, 3215.
32. Which number? I couldn't hear you.
15, 1 5.
15. Got it. AB equals 3 to the power of 2x. BC equals 3 to the power of x. What is this? What is the surface area of the cylinder?
Good, nice reading, very, very loud.
Thank you.
Feelings good when you for the 3215, right? Well, step number 1, regardless, you have to make a picture. And they said they have a cylinder. Let's make a cylinder. Practice to make these pictures. Okay, imagine this is a cylinder. And they provided this diameter, which is AB. And they provided this similar. It's supposed to be here, DC. And AB given. AB equals to 3 to power 2x. And BC equals to 3 to power x. What is surface area of cylinder? You know, if you have a cylinder, I show you a cylinder right now. Pretend you have a cylinder, only this cylinder with holes, right? This is cylinder, right? If I make a net, it becomes what? Rectangle. One more time. This is rectangle, and plus we have two circles related to bases, right? Let me make this a net. You know net, right, students? So I want to make this picture for you, and little by little we do this. So pretend if I make a net, this is a rectangle, and plus we have two circles, top and bottom. Not nice, but you can see length of this side equals circumference of each of these circles, right? So far so good. Again, look at this. Imagine I have here some circle, and I put like this. This is circumference of the circle. So based on this, I can write that area, surface area equals area of rectangle plus 2 areas of circles. So far so good. And keep in mind that area of rectangle to get this side, let's say this length. My length of rectangle equal to circumference of the circle. And circumference of circle equals 2 pi r. And this is r. Okay. If AB is diameter, radius would be AB over 2 or 3 to power 2x over 2. What is it? It's my radius. If I plug in this radius over there, here instead of radius, I have 2 pi times 3 to power 2x over 2. 2 and 2 cancel out. I will get this length. I can write this length equals pi multiplied by 3 to power 2x. What I use? I use this formula we covered with you many times. Circumference of any circle. And I just plug in what we have. Who understand up to this point, students? Hands up. What about Nicholas?
I understand.
Hands up. Well, how to find width? And width is given is BC, is width. And I put here this value in 3x. What is it? This is width. Okay. How to find area of rectangle? Area of rectangle, first grade. This is step number 1. This is step number 2. This is step number 3. This is step number 4. And this is step number 5. Area of rectangle, length times width, which is pi times 3 to pi times 3 to power 2x. This is length multiplied by width by 3x. 3x is, no, not 3x, 3 to power x. 3 to power x. I take a red color and remind you formula we studied with you. A to power m times a to power n equals a to power m plus n. Remember our basic of algebra we covered. Look at this. We have two terms with the same basis. And according to this formula, you can write it pi times 3 to power 2x plus x, which is pi times 3 to power 3x. This is my area of rectangle. I make it a little bit lower here to power 3x. It's area of rectangle. Now, step number 6. To understand this step number 5, raise your hand. I just plug in everything what we have and use basic of algebra. Now, how to find area of circle? And keep in mind, we have two area of circle. Area of circle, make some room here, equals to pi r squared. But since our r equals pi, plug in r times 3x, 3 to power 2x, and divide by 2 to the second power. I take a red marker and write another formula. A to power m to power n. You multiply powers, multiply exponents. Okay. And what you will get? You will get pi 3 multiply exponents to power 4x. And 2 to the second power is 4. I will write 4 right away. Only one suggestion, in order to not waste time, I use different color and multiply by 2, because why? Remember, we had two areas of circles on the top and the bottom, this and this. And you have to multiply this by 2. The next step, cancel out. 2 goes into 4 2 times. And you get area of 2 circles, pi times 3 to power 4x over 2. And finally, how to find total area? Add this plus this. Total area. Okay. So far, so good. I don't have too much room. I write here, step number 7. Area surface, or surface, equals, okay, pi times 3 to power 4x over 2 plus pi, or you can write 3 to power 3x times pi. Doesn't matter. Commute property. And this will be the answer. So what is difficult here? Nothing, except what you have to know how to operate with powers. Can you get this kind of question? Yes. This we can get it. Who understand this 100% so far, students? So don't be afraid. You have to know only basic. Don't memorize too much. You have to know area of rectangle, definitely area of square, how to find. For area of square, you have to know 2 formulas, not just side to second power, but half of diagonal to second power. Remember, is a relationship. Area of triangle, base times height divided by 2. Area for equilateral triangle. Who remember, who can tell without looking? Formula for equilateral triangle. Anybody? Use microphone. Tell us.
S squared square root 3 over 4.
A plus smiley face. Good job. Yes.
Okay.
And area of circle pi r square. Probably rhombus area. Who can remind me area of rhombus? Area of rhombus, right? And area of trapezoid. Area of rhombus. Who can tell me 2 formulas without looking?
Base times height.
Yes, it's for any parallelogram, and specifically for rhombus. Oh. 1/2 of product of diagonals, because in the rhombus, diagonals in rhombus mutually perpendicular. There's always 90 degrees for rhombus. So second formula equals 1/2. This is d1. I showed last time, you don't remember. d1 times d2. This is very important because imagine on the test, they don't have base, they don't have height. You're supposed to use Pythagorean to find all this stuff, or just plug in over there. Okay, and who can tell me area of trapezoid without looking? Anybody? Yes, go ahead. Trapezoid area.
Isn't it the first base plus the second base times 1/2 height?
Yeah, you can do this. So for trapezoid is base 1 plus base 2 divided by 2 multiplied by height. Very good. So again, I don't ask you to memorize a lot, just basic of basic. Rest of the simple logic. Why it's important? Because many questions based on this idea. Every year they give you questions related to shaded area. And shaded area sometimes very weird. But any shaded area, it's like you use in childhood zigzag puzzle. It's combination of simple shapes. And these simple shapes you must know. We have special session for shaded area. Every year they give this kind of questions, and they're not complicated. If you remember, we did questions, some of them for Mark Twain prep. So basically, I explained some of most frequent questions from this. packages, right? Let me see what we have here. Yes.
Can I go over, please, 7? I mean, 9.
What number? Say it again.
9.
5 or 9?
9.
9. Okay. Read this 9.
1 over A plus 1 over B plus 1 over C equal to 3, and volume equal to 144 centimeters cubic. What is the surface area of rectangle prism?
Okay, good. So what is Alexander? What is supposed to do? Step number 1. In any geometrical problems.
Draw a picture.
Absolutely. So number 9. Let me make this. Make a prism. You're supposed to have graph paper notebook for sure. It helps you a lot. Okay. This H, B, and this is C. And given 1 over A plus 1 over B plus 1 over C equals to 3, and volume equals to 144 cubic centimeters. They ask you surface area. This is given. This is find area of surface. Well, how to ideal situation? If you know dimensions ABC, right? You can easily do what? You can easily find surface area. Let me take what is given here. Step number 1. I use this space. 1 over A plus 1 over B plus 1 over C. They said it's equal to 3. How to add fractions? Fourth grade. LCD, least common denominator, ABC. Remember how we added fractions? Only here we have in parametrical form, in variables. So since this you multiply home, this by BC to get ABC. This you multiply by AC. And this you multiply by AB. What I'm doing, I'm adding these fractions. And if I add them up, what I'll have? BC, or let me arrange by letters. BC plus AC plus AB. Or I can write AC plus BC plus AB over ABC. And this equals to 3. For convenience, it's not 3, 3 over 1. Okay? Now, we teach trees. We have a companies where we teach trees. Trees is how to solve inventive problems, right? And in trees, we have idea of IFR, ideal final result. Pretend this ideal final result. How to find? How to find this answer they ask you? How to find area? Area would be, look at this. AC, area surface. Surface. AC multiplied by 2 plus BC, like I did today, multiplied by 2, and plus AC front back multiplied by 2. If I divide everything by 2, I can write that AC plus BC plus AC equals area of surface divided by surface by 2. Now look at this, what I have. This is exactly the same. Instead of this, I can write area of surface divided surface. Area of surface divided by 2. What is ABC? ABC is my volume, length times width times height. Divide by volume. ABC, this is volume. This is volume. Volume. And this area surface divided by 2. Okay. So far so good. And what is area surface divided by 2? This is actually given is 144. 144. Okay. So far so good. So this ACBC plus AB is area surface divided by 2 to volume. And this equals to 3 over 1. So what we get? Area surface divided by 2 multiplied by 144 equals to 3. How to find this one variable? Easy. Imagine this over 1. And you can write area of surface equals 3 times 2 times 144. If you multiply, you get the answer. Keep in mind, even though there are 3 unknown, but structure of this show that actually this is 3 steps problem. Who understand this 100%? 100. Yes.
In surface AC plus BC plus 8AC, you multiply by 2.
Last word I didn't hear. You did what?
You multiply by 2.
Yeah, multiply by 2. Why? Because look at this, simple logic. How to find, sorry, area front and back? You found this, multiply by 2. Area left and right. You found this, multiply by 2. Top and bottom. You found this, multiply by 2. Because every time we have 2 congruent areas. If you take any rectangle has 2 congruent areas. It's not rectangle, cube, right? With this one. Rectangular prism. This and this, this and this, this and this. Yes or no? Look, this rectangle. Front, back, left, rectangular prism, left, top, bottom, the same. So far, so good, students. Did I answer your question, Alexander?
Thank you.
Well, if you don't have questions, we don't have too much time, students. But actually, I practically explain you from each of these pieces some questions. And since you know formulas, you can easily solve anything what is left by yourself, and you redo these packages. I need to explain more topics in order you can solve it at home. Okay. Well, the next topic I find here. Next topic would be a similar polygon. Very important topic for this test. Similar polygons. In similar polygons, what we have, let's say you have two triangles, they're similar. And this ABC, this A prime, B prime, and C prime. You can use any letters. And we say that triangle ABC is similar, we name similarity sign, to triangle A prime, B prime, C prime. In similar triangle, corresponding angles are the same. And their sides always in proportion. So in similar polygon, sides are in proportion. Okay, you will read this all definitions in your handouts. We have it, right? But we have very important property to solve some problems. I give example. Property number one. Okay, if you don't have questions, when two polygons are similar, write it down. When two polygons are similar, then ratio of their areas equals to the square of linear ratios. I'll give an example. Let's say example one. I just make up. Let's say we have two triangles. It's related not only to any polygon, two triangles. And ABC and A prime, B prime, C prime. They similar. Given triangle ABC similar to triangle A prime, B prime, C prime. Ratio of these sides, let's say this side is 10 and this side is 3, corresponding sides given, inches for instance. And ratio of this, okay, let's say area of this one equals to, I just made up some number, 30 square inches. Find area of triangle A prime, B prime, C prime. Look at this students. We don't have bases. We have bases, but we don't have heights, right? And how to find area? Use this beautiful theorem, really beautiful. It solved many problems in one shot. Look at this. I can write by definition of this theorem. I would name it A2 for simplicity. Area 1 to area 2, like this side, to this side, to the second power. It's it. Just plug in numbers. Since area 1 equal to 30, I can overwrite 30 over A2 equals 10 to the second is 100. 3 to the second is 9. Cross 100 A2 equals to 270. Thirty times 9. Okay. Now, if I divide by 100 those parts, I instantly get the answer, 2.7. So area 2 equals to 2.7. In one line. So wherever you have, it's not necessarily you're supposed to have triangle, pentagon, hexagon. This is a beautiful formula. Have you seen, or maybe have you know about this was movie Titanic? Who knows about this movie, the Titanic, right? It was very popular a few while ago. You know what is Titanic, right? Who can tell me what is Titanic? Not movie, but what physically? What object is it? Anybody? What is Titanic?
A ship.
Ship. What do you know about this ship?
It's sunk.
Yes, and it's a small ship.
Big one.
One of the biggest at this time. You know how long it was? I believe it's about 289 meters long and 30 meters wide. And this time it was huge. One of the biggest ship in this time. And let me make a picture. For instance, this was huge ship, Titanic. I don't know how to make these drawings. Right? Titanic. And to make this movie, there's no triangle. You see, it's irregular shape over there. They do not build this Titanic again. They made a small model of this in Pavilion, right? You know this small model, imitation, similar to this one. And they had documentation of this Titanic. And let's say they know this side is, this length is about 280 meters, huge one. And in Pavilion, where they make a room, they make small ship like this. And let's say this length is, I don't know, for simplicity, is 20 meters or 29 meters. And they when they provide, they have documentation for this one, and they wonder how much paint they're supposed to buy. They knew how much paint they spent for this one, and you need to find how much paint. But paint depends on area. Bigger area, more paints. How to build this? They use the same formula. Look at this. Area 1 to area 2. Area 1 was given from documentation of this Titanic. And you can write area real Titanic. I put Titanic real. To area of 2 of this model, like 290 over 29 to the second power. If you simplify, it would be 10. It would be 100. Okay, 100 over 1. For A2 cross multiplication, A2 times 100 equals to area of Titanic. If we divide both part by 100, you instantly get area of this model imitation is exactly 100 times less than area of Titanic. Take amount of paint for Titanic, divide by 100, and they use this way. behind the scenes, this formula. Okay, who understands beauty of these formulas? When on the test they give similar shapes, and you don't have enough information, they even have height here. Even you have heights, it's faster to do this. It related or any two-dimensional object, this formula. Okay, and let me see if you, based on this, you can do your homework. Let me see this one. Yes. Practically, you have enough information. Okay. For instance, I have one of this problem. If the radius of circle is tripled, what can you tell about area? This from your homework. Let me write this one from. I read this one. Formula number 1. I modify problem from homework, otherwise it would be nice, would not nice to solve it. If the radius of a circle is I'm making sure 3 times bigger than the original or larger I put here. Okay. Then area, and you have to find how much area changes. Look at this. Make a picture. You have small circle, which area is the radius is x, and you have another one where the radius is not area, radius 3x, and this area 1, and this area 2, and area 1 to area 2 equals x over 3x to the second power. Cancel out. It would be 1 over 9. So area 2, you can say area 2 times 1 equals area 1 times 9. Okay. Or you can say nobody use 1 here. Area 2 becomes 9 times bigger than this one because of this formula. In one line. You can do another way, second way. Look at this, the second way. Area 1 equals to pi x to the second. Area 2 equals pi times 3x to the second. Or pi times 9x to the second. Area 1 to area 2 equals to pi x squared divided by 9 pi x squared. Cancel out. Would be 1 over 9. The same relationship. But in many situations faster. What about circumference? How changes circumference? If they ask you how change your circumference, look at this. I use this space. C1 equals 2 pi x. C2 equals 2 pi times 3x. 6 pi x. So C1 over C2 right here. 2 pi x divided by 6 pi x, 1, 3. So 1 over 3. And this straightforward. If it becomes 3 times bigger, new circumference, look at this, C2 times 1 is C2, equals 3 C1. Circumference also becomes 3 times bigger, because only area you have to take in second power. If they ask you home, what happens if a double, triple, whatever you have in your home, you can easily use two ways. This nice relationship and this one. You understand this so far? Okay, good, good, good. We have, I need a little bit more time, a little bit, not too much. Let me explain, otherwise you have, we have a strong curriculum here to finish. I need to tell you about solids as well, right? You know, solids, three-dimensional objects. And this approach is very similar to three-dimensional. Let me erase everything and write, I'll probably write over there. Okay, I use this space, okay, or this one. When two solids are similar, then the ratio of their volumes equals to the cube of linear ratios. It's related to any polygon, any solid. They must be similar. It's not necessarily a cube. It could be pyramid, cone, whatever you have. I give example. For instance, for simplicity, example number 1. I have two cubes, or it could be two prisms. Let's say I have two prisms, and they're similar. One is big and one is small. They're similar. What does it mean similar? The sides are in proportion. Okay. And let's say this side is I don't know, 15. Or let me use simple numbers. This is 30 and this is 10. Okay. And how much this volume bigger than this volume? Question is, look at this, how easy to do it in one shot. This is volume 1. Volume 1. And this is volume 2. According to this approach, volume 1 to volume 2 equals 30 over 10 to the third power. Cross it out. It would be 27 over 1. In one shot, we solve this easy problem. It's very practical. I remember a while ago, I explain students. So let's say you're going to shopping with your money, right? I give example. And let's say you decided to buy, understand up to this point. For 2-dimensional, we use square. For 3-dimensional, we use cube. It's it, all difference. I don't know what, let's say you decided to buy a watermelon or oranges, grapefruits, and we have this 3 fruits where radius is 1, all of them the same, radius is 1. Each of these fruit is $1, $1, $1. If you buy 3, you have 1 fruit where radius is 3. And it costs $3. Okay, versus. We have 2 scenarios. And you help your mummies, right? Scenario A, scenario B. And usually when they say sale in this different story, right? Stores, you see, wow, 3 for $3 and 1 for $3. Who would choose scenario A? Raise your hand to help your money. Okay, put your hands down. Who would choose scenario B? Who has no ideas? Let me use this formula. Let's say this is V1. I'm talking about one sphere. And this is V2. And they're similar. All spheres are the same. You can write V2 over V1 equals 3 over 1 to the third power. And this is equal to 3 times 3 times 3, 27 over 1. And V2 cross equals to 27 V1. If you buy this fruit, it's the same like you buy 27, this amount of matter in this amount of substance. In this one is like not 3, 27. If you buy 3, you have to subtract 3. And it's like 24 for free you're getting these fruits. Can you imagine this? Once for fun, I just spoke to a person who's selling these fruits. He has no idea about this. He thinks this is the same. It's even better. But if you're smart, you'll never buy this small garbage. You buy this one, you get like 27 fruits for the same amount of money. Is it impressive, student? What do you think? Behind the scene, this is formula. Who understands this 100%? Because we use cube, when you use solids, it's supposed to be cube. Cube, the third power, the third power. We almost finished. I gave one problem to solve from homework, right? To see how you understand. Yes.
Why did you make like 3 over 1 to power of 3, not a 2?
Because this is cube. Cube. Cube at this a cube, third power.
Oh, okay.
And this is a square, second power. Cube means the third power.
Okay, thank you.
So far, so good. If you go to a nice college, you study multidimensional words, different spaces, Minkowski space, etc. It's not necessarily 3-dimensional, it could be even more. But so far, this is what we have here. Let me solve problem. One problem with you. Okay, I choose any problems from here. For instance, I'm looking at more specific problem among these problems. Okay. Let me read everything. If the length, write it down, and width of a rectangle is not is of a rectangle are example triple the area is increased by how many percent? Okay, let me solve it together with you. You have a rectangle. Make a picture for rectangle. And this is, let's say, x, and this is y. And this area 1. After that, you make it bigger, not to scale, proportionally bigger. And this area 2, and this is 3x, and this 3y. Keep in mind, x and y is not necessarily the same, they're different. And I can, based on this, I can write of this one. I can make a ratio A2 to A1. Take any of the side, doesn't matter which, but corresponding side. As 3x to x to the second power. Why? If two shapes are similar, then ratio of their areas equals to square of linear ratio. Easy, like song, right? Nice song. Like lullaby, right? Look at this. After simplification, I will get 9/1. What does it mean? That area 2 cross equals to 9 area 1. Did I answer the question? No. I just found this is equals to 9 area 1. Now, like, remember which we covered chapter 5 and 6 percentage. How to find percent of increase? I don't have too much room, I continue here, over there. So this is step number 1. I just apply this theorem. Who understand this step number 1? Hands up. Who does not? Ask me questions, students. Then you are Eric. Okay, hands down. Now, step number 2. You increase is difference. What is the difference between new area and the first area? A2 minus A1. But since A2 equals to 9A1, minus A1 equals to 8A1. Area increased by 8A1. Now, how to find percentage increase? This is original initial value, right? Step number 3. Initial value A1 is 100%. And this my delta, which is 8A1. I have no idea. I can use X and Y because X and Y taken, I use Z. It's like your initial score was 70%, and new score you got 90%. How to find percent of increase? 90 minus 70, 20. 70, 100%, 20. I have no idea. Cross. A1 times Z equals 8A1 times 100. Divide by A1. Divide by A1. Cancel, 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 cancel. And you get Z equals to 800%. What I did, key thing, not how to find percent, which you studied in 5th grade for Mark Twain prep. Remember? We studied 3 different scenarios. But key thing, this one, polygons. So in one shot, you found new area. After that, just mechanics. Okay, you will not underestimate these questions, how powerful they are for solving many questions on the real test in one shot. Even you don't have enough information, you can do it in one shot. Okay, there are no dimensions of this and this? No. It's just a pool just 3 times bigger and instantly get answer. Okay, who understand today's topic? Hands up. Alexandra. See, yes. Will explain parents what is better to buy 3 oranges, 1-inch radius for $1 each, or 1 orange with 3 or whatever grapefruits with radius of 3 inches or $3. And you explain this is 27 more minus 3, actually 24 more oranges for free. It's beauty of geometry, very helpful. If you don't have any questions for today's lecture, students? If you don't have questions, I give you homework. Zero 0404 today, April. 0404. Read the notebook, read the mistakes. You know what is it, right? Chapter 13, exercise 7-9. You have to do it from scratch. 7-9. Mixture number 8. You're supposed to redo. At home, mixture number 9. You do test 26 polygons, 32 surface area, redo volumes, redo common core, curriculum standards from 1 to 22. What are you supposed to do? At home, you will get chapter 13. You have this exercise 10, which is very important, this one, about similarity of polygons. Yes. You get handout similarity polygons and solids, and make some adjustments and solids. And the next you're supposed to do, this is common core curriculum standard. Let me see how many left of these questions. How many questions left? We finished 22. So 22 is, keep in mind, it's not 22. Many of these missed questions, right? I will put numbers and managers. I will count everything. And I send you by email. Manager will make a picture. This is, we just practice 20 more minutes over time, but it was great, I believe, right? You know everything for homework. If you don't have any questions, students, have a nice evening. Be strong, be well. Enjoy math. Bye.
Bye.
Bye, students.
Bye.
Wake up, right? Take care.